Welcome to qnawire.
Hi everyone, so what we have here is two buildings located in LA and Denver. The buildings are identical and the atmospheric pressure in LA is 101 kPa and the atmospheric pressure in Denver is 83 kPa. We know the buildings are both maintained at a temperature of 21 degrees Celsius and the air within the buildings are changed 1.2 times per hour. What we're asked to find is the ratio of the heat losses between the buildings in each different city. So what we're going to do first is go ahead and write our energy balance. We know that the energy coming in minus the energy leaving is equal to the change in energy of the system. Now since we know that we're operating at steady state conditions, what we can do is we can set this change in energy of the system equal to 0, and we can say that the energy coming in is equal to the rate of the energy leaving. Now we can break down these constituents and say that the energy coming in is equal to Q dot in plus M dot H1, which is equal to energy leaving, which is M dot H2. Solving for Q in gives us a Q in equal to M dot H2 minus H1. Now using the definition of H, we can say that this is equal to M dot Cp T2 minus T1, and this is equal to Q dot in. Now we can actually go ahead and further say that M dot itself is going to be equal to the density of air times the air changes per hour times the volume of the building. So this looks like rho, the ACH, which is the air change, times volume, times Cp T2 minus T1. Now if we look at the heat infiltration ratio, the loss ratio, we can say that's equal, we'll just say that ratios are, and that's going to be equal to Q dot LA all over Q dot Denver. And we can go ahead and write that as saying that this is rho ACH volume Cp T2 minus T1 all in LA all over the same quantities, rho ACH volume of the building times Cp T2 minus T1 for Denver. Now as we can see here, all of these quantities are the same except for our densities. So what we're left with is this ratio is actually just going to be the ratio of our densities. So that's the density in LA of air over the density of the Denver air. Now by using ideal gas law, we can say that this is going to be equal to P0 R T0 all in LA all over the same quantities in Denver. So P0 R T0 in Denver. So as you can see, we're at the same temperature and our R's are going to be the same, so these cancel out. So what we're left with is a ratio of the pressure in LA all over the pressure in Denver. Now these are two quantities that are given to us, 101 kPa and 23 kPa, and this gives us an infiltration heat ratio loss equal to 1.22, and that's our final answer.